Implementing and maintaining road and pathway infrastructure is an important government objective in the state of Vermont. Already a leader in the development of multi-use corridors, Vermont continuously strives to implement innovative and improve existing transportation-based infrastructure. In keeping with this statewide goal, the Village of Essex Junction is striving to attain a sustainable, multimodal transportation network. The purpose of our senior capstone design project was to develop designs for a multi-use recreational pathway and a deteriorating stiff-leg culvert. The proposed path will run 1,146 feet along an Amtrak railroad corridor between Grove Street and Lincoln Street in the village center. The existing culvert, which spans Indian Brook, is located below Grove Street adjacent to the Essex Tech Center entrance. First, we will discuss the pathway. The problem with the existing area is that students and community members are using the corridor as an unofficial shortcut, which has become a major safety concern. In addition, there have been frequent occurrences of illicit activities and littering, which the village wishes to discourage. The goal of our design is to improve biker and pedestrian safety by providing an environmentally friendly and aesthetically pleasing design in order to promote safe and healthy behavior. In order to create a high-quality design, we conducted several surveys of the area, took soil samples, and measured all necessary dimensions. Throughout the design process, we made sure to follow all necessary codes and regulations for implementing a railway-adjacent path. These regulations included Federal Railroad Administration guidelines and ADA standards for accessible design. The path is required to have a 15-foot offset from the closest track, a width of 10 feet for adequate user passing space, a 4-foot-tall physical barrier to prevent user-train interaction, a total pathway slope less than 8.33%, and a cross slope less than 2%. We originally wanted the path to run the full length of the corridor, but due to the small amount of space at the north end, the total 1,148 feet was separated into two sections. The first 948 feet, as measured from the south end, was designed to run parallel to the tracks. The slope section was designed to run 102 feet and to have an end elevation difference of 5 feet, and that will meet all ADA grade requirements. To promote drainage of rainwater and snowmelt, the path will have a cross slope of 2%. A rain garden was designed to mitigate the effects of surface runoff from the pathway. We calculated for a 2-year, 30-minute storm that the new path area will generate 1.67 inches per hour in runoff, which according to the Vermont Rain Garden Manual warrants the use of a rain garden. After assessing the soil quality, we were able to calculate the appropriate area dimensions for the rain garden. The straight portion of the path will have a 2.5-foot rain garden, which will run parallel to it on the east side. The slope portion of the path will have a triangular rain garden that will also be oriented on the east side. The rain garden vegetation was selected from the Vermont Rain Garden Native Plant List. 5 plants were chosen based on their size and aesthetic quality. In addition to the garden vegetation, we also selected trees that can successfully grow in this area. The trees will be used to separate the pathway corridor from the housing that lies along Grove Street. For the second portion of our project, we conducted a complete redesign of the Indian Brook culvert. As there were no previous records regarding the culvert, we did not have any background information regarding how or when it was built. We collected data through multiple investigations to assess the overall condition of the structure to locate areas of concern. From visual inspection, we believe that the original culvert was designed for only one lane of traffic. Here, you can see discontinuity in the concrete where the additional lane was added. Another addition was added on the opposite side to accommodate a sidewalk. Here, you can see the newer concrete fill that has been added on top of the original culvert wing walls. The most significant deterioration is located directly below this sidewalk addition. The deterioration is more pronounced in this location due to the added weight of the sidewalk and the placement of the concrete wall with respect to the brook. On the southeast side, cracking has begun to occur along the interior corner of the wing wall, which also seems to be associated with the sidewalk addition. Here, you can see a missing chunk of concrete with cracks extending above. This deterioration is located at the seam of the original culvert and the addition of the second traffic lane. It was concluded that repairs to the structure would not be an economical solution due to their extensive and temporary nature. Instead, a complete redesign and replacement plan for the culvert was developed. The new culvert was designed according to AASHTO LFRD bridge design specifications. The design includes all previous modifications in addition to some added improvements, such as the incorporation of an additional sidewalk on the west side of the culvert. Recent major storm events have raised concerns as to whether the size of the current culvert can handle the stream flow during these events. The new culvert has been designed for a 100-year storm to prevent flooding on and around the road. The culvert spans Indian Brook, which has been classified as an impaired waterway at this location. The design incorporates a stream gauge to monitor flow and the overall health of the brook. We propose a stilling well will be attached to the culvert to measure head levels. Using the dimensions of the culvert, stream flow is calculated and stored in an attached data logger.